Hi, this is Dr. Stephen Jones. As promised, I have a way to look at the decision analysis table, and I'm not using the tree on this one. There's an example of that in your text, and there's an example of how to do this table in your text as well. But the problem that you have for this module asks you to complete a table like this with information, and I'm just going to show you this is how we do it, and then you have to make the analysis on your own based on the data and what you know of the situation. But let's go ahead and start off with this problem, and I've just made up the data here, so it's not based on a real problem or a problem in the text or anything like that. Here's your initial table and what it would look like, just like what you would see in the text there. We have XYZ ABC movies, and they've decided that they potentially could, let's say, make a big theater or a medium-sized theater or a small-size theater or no new theater at all. And in this situation, then, if they were to look out at the marketplace, they would take a look at the marketplace and judge it to be either the one that portended a robust future, one that said, well, it's just average is what's going on, or looking at a recession. And they have different probabilities for each of those. 30% chance there will be a robust economy, 40% chance for an average economy, and 30% chance that there'll be a recession. And there are different outcomes for each of those. I've made the numbers relatively simple just for us to use here in this example. And you can see what those are there on the screen for yourself. What we will be taking a look at is how you would calculate out the different blocks of information that you need in making your decisions out here. So we'll be looking at the expected value of perfect information. How much would the maximum be you'd be willing to pay for something? We'll be looking at expected monetary values, including minimum amounts over here to make judgments about minimizing the lowest payoffs, minimizing the amount that you could actually lose, or maximizing the amount of profit you might be able to make. We'll also be creating a regrets table down here. So if you didn't take advantage of a situation, how much profit might you be losing by not doing the alternatives, and then creating a minimax situation and the expected values, minimum values for profit loss regrets out there. So let's take a look at each one of these. So starting off with the expected value of perfect information, you're going to take a look at the maximum payoff that you get under each scenario. And in this situation, looking at the maximum payoffs, your perfect information is going to be 4,000 under a robust economy, 2,000 under an average economy, and nothing under a recession. So if you have a belief that the recession is coming along, you shouldn't be paying for any extra information, because under any of the new facilities you're going to lose money, so you might as well do nothing. If you're going to do nothing, And you don't need new information, do you? Because you're going to do nothing. In any case, that's how we are calculating the expected value of perfect information. Find the maximum value that goes in here in each one of these. Now, you do that through Excel through a formula where you ask for, in this cell here, you ask for the maximum value of, whoops, sorry about that. Let's go back. You ask for the maximum value within this column. Or if you were going across this way looking maximum, you'd ask for maximum in that row. Or if you want the maximum for a whole table, you can do that as well. So if you'll take a look at the step-by-steps that they show you in Excel, you'll be able to find out how to do that, to write that formula if you forgot. In expected monetary value, you're going to be taking the value here of the probability versus the outcome that's expected, and you're going to do that across that alternative that you're looking at. So 30% times 4,000 plus 40% times 2,000 plus 30% times a negative 2,000, and you're going to sum that up. Remember, it's the sum of the probability times the outcome for each one of those, and that gives you expected monetary value for this. So large facility is 1,400, medium 1,200, small 850, and no new is zeros all the way across, because again, 0 times anything is 0, no matter how many times you sum it up. So when you look at that and you look at the summed values here, it comes up that 1,400, excuse me, let's go back. 1,400 happens to be the maximum, and pardon me, but there is a typo in my slide. I apologize. That maximum should be 1,400, not the 0 that you see. And now, in the magic of pausing, I have also included my arrows. So that's how it should look, not the way it looked before. It should be 1,400 on there, not 0. And that's what you would take across. So you would find the maximum for each alternative, and then the expected value for each alternative, and then you would find the maximum of those, and that's what you're looking for. So the maximum expected monetary value goes here, and it also would go here, because you're going to compare values here. So if you're looking for Maximin and Maximax, Maximin, remember, you're trying to find how to maximize the minimum that you're going to get. So if things turn out bad, what's my best minimum outcome? And then Maximax is, if things turn out well, how do I get the best value? And you look at each of those. So here you're doing the minimum value, so what's the smallest value here for each of these options? 2,000 loss, 1,000 loss, 500 loss, and 0 loss, because you, again, did nothing here. So what's the worst in each row? And then this one is, what's the best of these worsts? And that is your Maximin. And for Maximax, you're going to find what's the best in this row and put it over here. And so you have 4,000, 3,000, 2,000, 0. And so this cell right here is, what is the maximum of all of these? And that's the 4,000. And those then transfer down here. So your your Maximin goes here, and your Maximax goes there. Now finally, your Minimax is going to be, how can I minimize my maximum regret? So which of my options out here gets me to the best outcome that's a possibility? So you take the expected value of perfect information here minus the outcome that shows up here. So the first one is perfect information. If I had that, then 4,000 minus that 4,000 gives me a 0. So you get those numbers like this for each column. How much would I regret if I had perfect information? You wouldn't regret anything for these two or that one down there. Then you want to take, in terms of an expected value, you take the expected monetary value for each option. So 30% times 0 plus 40% times 0 plus 30% times 2,000 gives you 600. So again, you're summing up all of those. So for each option, you come up with what your expected value is on this, and then you try to find the minimum of these. So what's the maximum regret that you could find here, and minimize that out, and that's going to be 600. That's the minimum of those expected ones. But if you want to look at the maximum for each one, how much could you regret? The highest value here is 2,000, 1,000, 2,000, and 4,000. And then you look for this minimum, and this is the minimum max here. So this is the minimum expected loss. You would be trying to get rid of that one. And this is the minimum maximum regret that you would have. So that's the mini-max cell right there. Now, we don't put the minimum EMV in there. We do the maximum EMV. But it's worth looking at so that you see what your value is, because it says here that given the expected values that are coming through, we would expect that this is your best option. The large one is the best option here, the large facility, because it happens to minimize what your expected regret might be. And in this situation, when we minimax, we'd be choosing the medium facility because it minimizes the maximum regret that you might have, or opportunity loss that you might find. And that goes up in this cell right here. So if you were looking at your decision points, then if you wanted to maximize the most profit that you could get out of it, you'd choose the large facility. If you wanted to hedge your bets and you wanted to minimize how much you could lose in a bad situation, then you would want to max them in, and that means you would take no new facility as your option. If you wanted to go with the option that provided you with the best expected monetary value, which one is most likely to get you positive cash flow, then you're going to go again with the large facility because it gets you the 1,400. And if you wanted to minimize the maximum opportunity loss that you're looking for, then you're actually looking at the medium facility again. So among these, you'd be looking at the medium facility, at the large facility, and at no facility. But in no situation does it appear that the small facility happens to be a good option on any of these decision modules. I wouldn't necessarily say, well, go with large, because large is 3 times, see the 600, as well as the 4,000 and the well, there we go, and the expected minimum value there. So EMV, the Maximax, and the minimum EMV all happen to go for the large facility. Medium facility happens to be best in terms of the Minimax, and then no new facility is the best one if you're trying to max him in. And small doesn't come up at all. But you really can't look at it like that because you're not averaging things out. You have to understand what level of risk are you willing to take and where are you willing to go in terms of deciding which situations are best as well. And then remember, there may be ethical or legal, cultural reasons in making your decisions as well. This just helps you to see what some of your options are.